Very good morning to all of you. Sorry, very good. We have almost completed one chapter. A couple of reactions remaining. We will discuss that and then we'll proceed. Just give me a minute. Yes, very good evening once again. So we had a couple of questions remaining from our last worksheet. Adanna mugsi ನಾವು next chapter ಹೋಗೋಣ. Okay. These were questions on quantitative analysis. As last class, we had discussed some methods for estimation of nitrogen, estimation of carbon, hydrogen, halogens, sulfur, phosphorus. ಒಂದೆರಡು ಪ್ರಶ್ನೆ ಉಳ್ಕೊಂಡಿತ್ತು. ಆ ಎರಡು ಪ್ರಶ್ನೆ ಸಾಲ್ವ್ ಮಾಡಿ ನಾವು ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ ಹೋಗೋಣ. ಓಕೆ, ಎಸ್, ಲೆಟ್ ಮೀ take up this question number 29. Yes, 0.1890 grams. This is the mass of the given organic compound. See, when such a number or such a value is given in CET or Neet, please approximate ಅದನ್ನ approximate ಮಾಡಿ. ನೀವು 0.1890 ಅಂತ ತಗೊಂಡ್ರೆ ನಿಮ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಲೆಂಗ್ತಿ ಆಗುತ್ತೆ, ಕಷ್ಟ ಆಗುತ್ತೆ. ಓಕೆ, ತುಂಬಾ ಟೈಮ್ ಕನ್ಸ್ಯೂಮ್ ಆಗುತ್ತೆ. therefore approximated 0.1890 ನ you can approximate it to 0.2 ಮಾಡಿದ್ರೆ calculations becomes easy. See, I can approximate this to 0.2 grams. Then this is the mass of organic compound. This gives 0.287. Nodi matte you have a number like this, 0.287. These are not user friendly numbers. So idanna ನೀವು approximate ಮಾಡಿದಾಗ ನಿಮ್ಮ calculations easy ಆಗುತ್ತೆ. Okay, so 0.287 I can approximate it as 0.3. Please check. 0.3 grams approximate ಮಾಡಬಹುದು. So 0.2, 0.3 is easier to work with. Okay, this gives silver chloride determined by Kreis method. That is the name of the method. You have to find out the percent mass of chlorine in the compound. You need to find out the percentage mass of chlorine. Okay, yes. Now what is the formula for percentage of chlorine? Percentage of chlorine in an organic compound or in a compound, percentage of chlorine is equal to atomic mass of chlorine 35 into mass of silver chloride formed. ಎಷ್ಟು ನೋಡಿ, mass of silver chloride 0.3 grams. 0.3 divided by molecular mass of silver chloride, AgCl. Molecular mass of silver chloride, molecular mass of AgCl is equal to, you need to add up the atomic masses. Silver is 108 and chlorine is 35.5. So this will be 143.5. Molecular mass of AgCl 143.5 into mass of the organic compound, which is 0.1890. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ನಾವು ಅದನ್ನ 0.2 ಅಂತ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ for convenience of our calculations. Okay, so it is 0.2 into 100. ಈಗ ಇದನ್ನ ಹೇಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋದು? ರಿಮೆಂಬರ್, you are not supposed to use any calculator in entrance exams. Calculators allowed illa. Then how do you simplify? Again, you know, 35 2 times is 70. 35 4 times is 140. So 35 and 143 almost approximate. Nano, I can say 35.5 and 143.5, almost 4 times. 35 into 2 70, 70 to 2 140. So it is almost 4 times anta ankobodu. Okay, so it is now 0.3 by 0.2, which can also be taken as 3 by 2 into 100. This will be equal to 102 is 50. 50 into 3 150. 150 by 4. 150 by 4, easy. ನೋಡಿ 150 by 2 75. 75 by 2 37.5. 37.5. See, closest option 37.5. 37.5 is a correct answer. Percentage of chlorine is 37.5. So this is how you can estimate the percentage of chlorine or any halogen in an organic compound. Okay. Now we'll move on to the last question. Last question is related to Yeldahl's method. Yeldahl's method is a method to estimate nitrogen. I will show you the formula once. Look at that formula and then solve the question. Okay. Once the formula nanu matte present martini for those who are not present for our previous class. You can just have a look at it once and then we'll check our answers. Yes, this is for halogen. Yeah, this is Yeldahl's method. Nodi, percentage of nitrogen. There are two formula. ಎರಡು formula ಇದೆ. ಯಾವ formula na use ಮಾಡಬೇಕು ಅಂತ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. Okay? You should know when are you supposed to use the given formula. Just a second. Okay. Yeah. Now please check the formula. First one. 1.4 into volume of acid used into basicity into molarity divided by mass of substance. ಈ ಫಾರ್ಮುಲಾ ಯಾವಾಗ ಯೂಸ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ when you know the volume of the acid used. When you know the volume of the acid used. In some cases, instead of knowing the volume of acid used, you will be given volume of the base that is used to estimate the amount of acid. In that case, you should use the second formula step. Okay. So, nenpitkoli. Case 1, where you know the volume of the acid used. Case 2, when you know the volume of the base used for titration of excess of sulfuric acid. Okay. Yes. Now, let us go to the next slide. Last problem nodana, question number 30. Formula nodkondiddira alva? Now we'll check out the solution for this. Question number 30. Yes. Ammonia evolved from 0.5 grams of organic compound in Yeldahl's experiment requires 29 ml of 0.2 molar sulfuric acid for complete neutralization. The percentage of nitrogen is. Percentage of nitrogen is. Okay. Now, here, let's understand the problem. Let me take a pen. Yeah. Let me highlight it. See, this is Yeldahl's experiment where you are given volume of sulfuric acid. Volume of sulfuric acid ಕೊಟ್ಟಿದ್ದಾರೆ. ನಾನು ಆಗಲೇ ಹೇಳಿದಾಗೆ volume of acid ಗೊತ್ತಿದ್ರೆ ಯಾವ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ತೀರಾ? Percentage of nitrogen is equal to 1.4 into volume of acid used into basicity into molarity of the acid divided by mass of organic compound. Mass of organic compound. So, let me substitute the values now. 1.4 into V, volume of acid used. Look at the volume, ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ 29. ಅದನ್ನ 29 ಅಂತ ತಗೊಳ್ಳೋ ಬದಲು 30 ತಗೋಬಹುದು. 30 ತಗೊಂಡ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಈಸಿ ಆಗುತ್ತೆ, ನಾನು ಆಗಲೇ ಹೇಳಿದ ಹಾಗೆ. ಓಕೆ. Into basicity. Basicity ಅಂದ್ರೇನು? I had explained this last class. For sulfuric acid, H2SO4, there are two replaceable hydrogens. Two replaceable hydrogens. Two replaceable hydrogen atoms. For HCl, there will be only one replaceable hydrogen. One replaceable hydrogen. Okay. So this is what is called as basicity. Number of replaceable hydrogen atoms is called basicity. Okay. So sulfuric acid ಆಗಿರೋದ್ರಿಂದ basicity value ನೀವು 2 ಅಂತ ತಗೋಬೇಕು. Therefore, I'll take it as 2 here into molarity 0.2. This is 0.2 divided by mass of the substance 0.5 0.5. Okay, ಇದು simplify ಮಾಡೋಣ. This will be equal to 1.4 into 30 into 2 into 2 into 10 power minus 1 by 5 into 10 power minus 1. 0.2 ನ ನಾನು 2 into 10 power minus 1 ಅಂತ ಬರಿಬಹುದು. 0.5 ನ 5 into 10 power 1 10 power minus 1 ಅಂತ ಬರಿಬಹುದು. ಓಕೆ, ಸೊ 10 power minus 1 10 power minus 1 gets cancelled. ಈಗ ನೋಡಿ 5 and 30 6 times ಆಯ್ತು. 2 into 2 4 4 into 6 24. Now this will be 24 into 1.4. 24 into 1.4. ಮತ್ತೆ ನೀವೇನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿಲ್ಲ, ಈ ತರ ಅನಲೈಸ್ ಮಾಡಿ. ಸಿ ಮತ್ತೆ ಡೀಟೇಲ್ಡ್ ಆಗಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕಾಗಿಲ್ಲ. 24 into 1 is 24. 24 into 2 is 48. 24 into 1.4 must be a number between 24 and 48. ಅದೆರಡರ ಮಧ್ಯೆ ಬರೋ ಸಾಧ್ಯತೆ ಇದೆ. Okay, so that will be approximately equal to 36. Closest option to 36, 32.4. 32.4 ಆನ್ಸರ್ ಆಗುತ್ತೆ ನೋಡಿ. 1.4 into 30 into necessity 2 into molarity 0.2 divided by mass 0.5. 0.2 0.5 2 ಮತ್ತೆ 5 ಆಗುತ್ತೆ. Then 5 and 36 times 2 into 2 4 4 into 6 24 24 into 1.4 is almost 36. Closest 32.4. Highlight ಮಾಡಿ 32.4 easy. That is the correct answer. Okay, so 1 second, let me take the next slide. Yeah, so the correct answer is 32.4. With this we complete our first chapter. Illi first chapter mugitu. Now we'll take up our second chapter from your first PUC organic chemistry. Okay, let me present the next slide. Just give me a minute. The second chapter for discussion is hydrocarbons. Hydrocarbons ಅಂದ್ರೆ ನಿಮಗೆಲ್ಲ ಗೊತ್ತು. These are compounds which contain carbon and hydrogen only. ಮತ್ತೆ ಬೇರೆ ಯಾವ ಎಲಿಮೆಂಟ್ ಇರೋದಿಲ್ಲ. Okay, these are compounds which contain carbon and hydrogen only. Just a second. Yes, compounds containing carbon and hydrogen only. Okay, right, so we are going to now study about these compounds. There are 4 types of hydrocarbons in this particular chapter that we are going to discuss. Yavyadadu, check it out, let me make a list. 1, we'll start with alkanes. ನೀವು ಇದನ್ನೆಲ್ಲ ಫಸ್ಟ್ PUC ನಲ್ಲಿ ಓದಿದ್ದೀರಾ. ಇಟ್ಸ್ ಜಸ್ಟ್ ಅ ರಿವಿಷನ್ ಆಫ್ ದಿಸ್. ಓಕೆ, alkanes, ಅದಾದ್ಮೇಲೆ alkenes, after that alkynes, and then at the end we'll discuss aromatic hydrocarbons. Aromatic hydrocarbons. Okay, so we'll take it up one by one. First, before taking up the concept for discussion, we should know how many questions were asked in the previous years. CET ಪೇಪರ್ಗಳಲ್ಲಿ ಮತ್ತೆ ನೀಟ್ ಪೇಪರ್ಗಳಲ್ಲಿ ಈ ಚಾಪ್ಟರ್ ಇಂದ ಎಷ್ಟು ಕ್ವಶನ್ಸ್ ಬಂದಿತ್ತು? ಇಫ್ ಯು ಲುಕ್ ಅಟ್ ದ ಡಾಟಾ ಫ್ರಮ್ 2015, 2015ನೇ ವರ್ಷ 15 ನೋಡಿದ್ರೆ 2019ವರೆಗೂ ಆಲ್ಮೋಸ್ಟ್ ಪ್ರತಿ ವರ್ಷ ಒಂದೊಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ದಾರೆ, ರೈಟ್? And only in 2018 there were 2 questions asked. Other than that, ಪ್ರತಿ ವರ್ಷ ನಿಮಗೆ ಈ ಚಾಪ್ಟರ್ ಇಂದ ಆಲ್ಮೋಸ್ಟ್ 1 ಕ್ವಶನ್ ಕೇಳಿರ್ತಾರೆ, ಮೇ ಬಿ ಮ್ಯಾಕ್ಸಿಮಮ್ 2, ನಾಟ್ ಮೋರ್ ದೆನ್ ದಟ್. ಅದೇ ನೀಟ್ ಅಲ್ಲಿ ನೋಡೋಣ. ನೀಟ್ ಅಲ್ಲಿ ಟ್ರೆಂಡ್ ಹೇಗಿದೆ ನೋಡೋಣ. ಓಕೆ, ನೀಟ್ ಐ ಥಿಂಕ್ ಐ ಮೇ ನಾಟ್ ಹ್ಯಾವ್ ದ ಟ್ರೆಂಡ್ ಫಾರ್ ನೀಟ್. ಓಕೆ, ನೀಟ್ ಅಲ್ಲೂ ಆಲ್ಮೋಸ್ಟ್ ಇಷ್ಟೇ ಇರುತ್ತೆ. ಒಂದು ಕ್ವೆಶ್ಚನ್ ಪ್ರತಿ ವರ್ಷ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಇಂದ ಬರುತ್ತೆ, ಹೆಚ್ಚಂದ್ರೆ 2 ಬಂದಿರುತ್ತೆ ಅಷ್ಟೇ. ಸೊ ಸಿಇಟಿ ನಾದ್ರೂ ಆಗ್ಲಿ ನೀಟ್ ಆದ್ರೂ ಆಗ್ಲಿ ವೇಟೇಜ್ ಈ ಚಾಪ್ಟರ್ ಇಂದ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಇರುತ್ತೆ ಅಥವಾ ಮ್ಯಾಕ್ಸಿಮಮ್ 2 ಇರುತ್ತೆ. ಮೋಸ್ಟ್ ಆಫ್ ದ ಕೇಸ್ ಇಸ್ 1. ನೀವು ಇಲ್ಲಿ ನೋಡಿದ ಹಾಗೆ ಯಾವುದೋ ಒಂದು ವರ್ಷ 2 ಕೇಳಿದ್ರು ಅಷ್ಟೇ. ಓಕೆ, ರೈಟ್. ನೌ ಲೆಟ್ಸ್ have a look at the classification. Yes, this is how hydrocarbons are classified. Classification of hydrocarbons, you can classify them as open chain compounds or closed chain compounds. Open chain compounds andre they will have carbon atoms arranged either as a straight chain, either a straight chain ibodu, or it can be branched. It can also be branched like this. See, then you have one more carbon atom here, one more carbon atom here. So all these are open chain compounds. Closed chain andre 2 carbon atoms of a chain are joined end to end. Okay, they form a ring. That is what is called closed chain. Itara carbon, let me write set of 6 carbon atoms here. Yes, nodi 6 carbon atoms here. Okay, this is what is called a closed chain compound. Okay, right. So under this, under open chain compounds, you again have saturated and unsaturated. Okay, those who are in the Zoom session now, those who are in the live online session, you can chat, send in your chat response. When do you say a compound is unsaturated? Unsaturated anta yavag heltira? What type of carbon-carbon bonds do you expect in an unsaturated? You can send in the chat response. Let me see. Yes, very good. Jyoti says when there is double bond or triple bond. Very good. Aishwarya says double bond or triple bond. That's right. So whenever there is a double bond or a triple bond, you say the compound is unsaturated. When there is only a single bond, the compound is saturated. Saturated compounds are called alkanes. Unsaturated compounds can be of 2 types. Alkenes or alkynes. Very good. Very good. All of you correct. Okay. That's about open chain compounds. Open chain compounds are ethera irutte. Okay. Alkanes, alkenes, alkynes. Similarly, closed chain alli nimge 2 ತರ ಬರುತ್ತೆ. Okay. Alicyclic, aromatic. Okay. Alicyclic ಅಂದ್ರೆ see, if an open chain compound is connected end to end, carbon to carbon, that becomes alicyclic. It has properties. It will have properties very similar to other open chain compounds like alkanes, alkenes, and alkynes. Hence, you call them alicyclic compounds. Aliphatic nature na resemble ಮಾಡುತ್ತೆ. ಅದಕ್ಕೆ ಅದನ್ನ alicyclic compounds ಅಂತ ಕರಿತೀವಿ. On the other hand, the other type is aromatic compounds. These compounds are characterized by extremely high stability. Their stability will be very, very high. Okay. The word aromatic comes from the word aroma, which means odor. So all these compounds which had pleasant odor were thought to be aromatic, but now we know the actual reason is their extraordinary stability. ಇಲ್ಲಿ 2 ತರ ಇರುತ್ತೆ. ಬೆಂಜಿನಾಯ್ಡ್, ನಾನ್ ಬೆಂಜಿನಾಯ್ಡ್. ಬೆಂಜಿನಾಯ್ಡ್ ಅಂದ್ರೆ ಬೆಂಜಿನ್ ತರ ಸ್ಟ್ರಕ್ಚರ್ ಇರೋದು. ಓಕೆ, ಸೊ ನಿಮ್ಗೆಲ್ಲ ಬೆಂಜಿನ್ ಸ್ಟ್ರಕ್ಚರ್ ಗೊತ್ತಿದೆ. This is benzene structure. All compounds which have benzene structure, they are benzenoid compounds. Those which are aromatic but do not have benzene structure. Itara, nodi. Cyclopentadienyl anion. Cyclopentadienyl anion. Right? These are aromatic, but they don't have benzene structure. Then you call them non-benzenoid aromatic compounds. So this is the broad classification of hydrocarbons. Okay. Now we'll make a beginning with alkane. First category, alkanes. As you all rightly pointed out, alkanes are saturated hydrocarbons. Alkanes belong to a series of homologous members, which are represented by general formula CnH2n+2. ನಾವು ನಮ್ಮ previous chapter ಅಲ್ಲಿ ಇದನ್ನ ಕಲ್ತ್ಕೊಂಡಿದ್ವಿ. All members of homologous series can be represented by one single formula. You call it general formula. That formula is CnH2n plus 2. Okay, and you have many examples here: methane, ethane, propane, and so on. Methane is natural gas. Okay, you have mixture of these alkanes, which constitutes LPG, liquid petroleum gas. So all these compounds are very good fuels. They have good calorific value. Okay, next. That is about the introduction part. Let's check out next, related to structure. Okay, now alkanes have carbon atom with sp3 hybridization. See, this is sp3 hybridization. One second, let me mark it. Just, yeah, sp3 hybridization. And for sp3 hybridization, the corresponding shape is tetrahedral shape. Recollect all these things. Tetrahedral shape. Okay, so that's about the structure. So in an alkane, you can always expect carbon atom to be in sp3 hybridized state, and hence it will have a tetrahedral orientation of bonds. Coming to nomenclature, naming ನೋಡೋಣ. ನಾವು ಹಿಂದಿನ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ನೇಮಿಂಗ್ ಬಗ್ಗೆ ಕಲ್ತ್ಕೊಂಡಿದ್ವಿ. So I'll just be explaining it very briefly. The root word or to the root word, you'll add the primary suffix "ane." Hence, you call these compounds alkanes. Okay, you count the number of carbon atoms. From that, you get the root word. To that, you add primary suffix "ane." That's how you get the name of alkanes. That is about nomenclature. Okay. Then isomerism. Alkanes show chain isomerism. Ready? Mainly chain isomerism under structural category. They also show conformational isomerism under stereoisomerism category. So chain isomerism ಏನು ಅಂತ ಗೊತ್ತು ನಮಗೆ. ನಾವು ಇದನ್ನು ಕೂಡ ಹಿಂದಿನ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. Chain isomerism is a type of structural isomerism where compounds will have the same molecular formula, but they will differ in the arrangement of carbon atoms. Okay, they will differ in the carbon arrangement in that framework of carbon atoms. Okay, ಇಲ್ಲಿ ನೋಡಿ examples ನೋಡಿ. First example, 4 carbon atom straight chain ಅಲ್ಲಿ ಇದೆ. They are arranged in a straight chain. Second example nodi, isobutane. It is branched. Therefore, you say, okay, the carbon arrangement or the carbon framework of the compound has changed. Such isomers are called chain isomers. Okay? Yes. Next slide. Nomenclature aitu, classification aitu. Now, methods of preparation. How do you prepare alkanes? Illinda nimge organic reactions shuru agutte. ಇಲ್ಲಿವರೆಗೂ ನಾವು ಬರೀ ಆರ್ಗ್ಯಾನಿಕ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಬಗ್ಗೆ ಓದ್ಕೊಂಡಿದ್ವಿ. ಹೌ ಟು ನೇಮ್ ಇಟ್, ಹೌ ಟು ಕ್ಲಾಸಿಫೈ ಇಟ್, ಐಸೋಮೆರಿಸಮ್ ಹೇಗೆ. ಓಕೆ, ನೌ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲುಕ್ ಅಟ್ ಆರ್ಗ್ಯಾನಿಕ್ ರಿಯಾಕ್ಷನ್ಸ್ ಸ್ಟಾರ್ಟಿಂಗ್ ವಿತ್ ಮೆಥಡ್ಸ್ ಆಫ್ ಪ್ರಿಪರೇಷನ್ ಆಫ್ alkanes. Now please recollect these methods one by one. First method, method 1, hydrogenation of unsaturated hydrocarbons. ನಾನು ಆಗ್ಲೇ ನಿಮ್ಗೆ ಒಂದು ಪ್ರಶ್ನೆ ಕೇಳಿದೆ, unsaturated hydrocarbons ಅಂದ್ರೆ ಏನು ಅಂತ. Most of you gave me the answer. It is alkenes or alkynes. Yes. If an alkene or an alkyne is made to react with hydrogen gas, nodi illi, made to react with hydrogen gas at a high temperature, high pressure, in presence of metal catalysts like platinum, palladium, nickel, etc., the unsaturated compound gets converted to saturated compound, which is an alkane. Illi ಏನು ಆಗ್ತಿದೆ? Very simple. 2 hydrogen atoms are getting added across the double bond ಅಷ್ಟೇ. See, double bond irutte. You have hydrogen getting added across the double bond. So you get this. This pi bond, one pi bond will be broken, and one pi bond, when broken, gives rise to 2 new sigma bonds. Then if you break one pi bond, that opens up 2 new sigma bonds, and that gets attached to hydrogen ಅಷ್ಟೇ. ಹೈಡ್ರೋಜನ್ ನ ಸುಮ್ಮನೆ ಡಬಲ್ ಬಾಂಡ್ ಗೆ ಆಡ್ ಮಾಡಬೇಕು. ನಾವು ಇನ್ನೊಂದು ನೀವು ನೋಟಿಸ್ ಮಾಡಿರ್ಬೇಕು ಇಲ್ಲಿ. I don't know how many of you noticed it. For alkene, it is only shown as 1 mole of hydrogen. Whereas for alkynes, 2 moles of hydrogen shown. 2 moles of hydrogen shown. Can anyone tell me the reason? Yanadu Karna Hetira? You can send in the chat. Why for alkene, you have shown only 1 mole of hydrogen. For alkyne, there are 2 moles of hydrogen. Yake? Anybody? Come on. One answer ಬಂದಿರೋದು solubility ಅಂತ ಇಲ್ಲ. Solubility answer ಅಲ್ಲ. ಯಾಕಿರಬಹುದು? Okay, ಇನ್ನೊಬ್ರು ಏನೋ ಟೈಪ್ ಮಾಡಿದ್ದಾರೆ, but I am not able to make out what that is. Okay, probably what Ravi is trying to tell is 2 pi bonds ಇದೆ ಅಂತ. That's correct. If you are meaning pi bonds there, then it's right. Yes, 2 pi bonds. 2 pi bonds. Okay. Yes. Alkynes have 2 pi bonds. Therefore, they take up 2 moles of hydrogen. Alkenes have only 1 pi bond. Therefore, they take up only 1 mole of hydrogen. Very simple. Okay. This is method number 1. Aito. Method number 2. Reduction of alkyl halides. Reduction andreno. You remove a non-metal and add hydrogen in place of it. See, illa ade martha idira. RX haloalkane, which contains halogen. X here is halogen. In the compound, halogen is replaced by hydrogen. This is what is called as reduction. Halogen atom replaced by hydrogen. Halogen atom replaced by hydrogen atom. ಈ process na reduction ಅಂತ ಹೇಳ್ತೀವಿ. ನೀವು ಯಾವಾಗಲೂ ಅಷ್ಟೇ ನಾನ್ ಮೆಟಲ್ ನ ಹೈಡ್ರೋಜನ್ ಇಂದ ರೀಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ಅದು ರಿಡಕ್ಷನ್ ಆಗುತ್ತೆ. ಮೆಟಲ್ ನ ಆಕ್ಸಿಜನ್ ಇಂದ ರೀಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ಅದು ಆಕ್ಸಿಡೇಷನ್ ಆಗುತ್ತೆ. ಓಕೆ, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಮತ್ತೆ ಇದನ್ನೆಲ್ಲ ಮಾಡೋದಕ್ಕೆ ನಿಮ್ಗೆ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ಸ್ ಅಥವಾ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ಸ್ ನ ಸಹಾಯ ಬೇಕು. ಹಾಗೆ ರಿಡಕ್ಷನ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. ಓಕೆ, ಸೊ ರಿಡಕ್ಷನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ನಿಮ್ಗೆ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ಸ್ ಬೇಕು. ಆಕ್ಸಿಡೇಷನ್ ಮಾಡೋದಕ್ಕೆ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ಸ್ ಬೇಕು. ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ? ರಿಡಕ್ಷನ್. Therefore, we would take the help of reducing agents. ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡಿರೋ reducing agent ಯಾವುದು? See, zinc in acid, zinc in acetic acid. ಅದು ನಿಮಗೆ ಸರಿಯಾಗಿ ಕಾಣಿಸ್ತಿಲ್ಲ ಅಂದ್ರೆ ನಾನು ಮತ್ತೆ ಬರಿತಾ ಇದ್ದೀನಿ. Zinc in acetic acid, CH3COH, can be a good reducing agent. Okay, this is reduction of alkyl halides. Okay, method number 3. Yes, now you have a very popular name reaction called Wurtz reaction. ಇದು ನಿಮಗೆ ಸೆಕೆಂಡ್ ಇಯರ್ ಅಲ್ಲಿ ಒಂದು ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಯಾವ ಚಾಪ್ಟರ್ ಅಂತ ಹೇಳ್ತೀರಾ? You'll get it in a chapter in second year. Can anyone tell me which chapter? ಸೆಕೆಂಡ್ ಇಯರ್ ಅಲ್ಲಿ ಒಂದು ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ನೀವು ವರ್ಡ್ಸ್ ರಿಯಾಕ್ಷನ್ ಓದ್ತೀರಾ. ಯಾವ ಚಾಪ್ಟರ್ ಅದು ನೆನಪಿದ್ಯಾ? ಹೇಳಿ ನೋಡೋಣ. ನಾಟ್ ರಿಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್. ರಿಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ನೀವು ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಓದ್ತೀರಾ. Come on. ನೋಡಿ ಯಾವ ಕಾಂಪೌಂಡ್ ಇದೆ as a reactant? No, I am not getting any answer here. Easy. Haloalkanes. Haloalkanes chapter ಅಲ್ಲಿ ಮತ್ತೆ ನಿಮಗೆ ವರ್ಡ್ಸ್ ರಿಯಾಕ್ಷನ್ ಬರುತ್ತೆ. Okay, so this is a reaction which is there in your first PUC syllabus as well as second PUC syllabus. So in words reaction, what happens? Haloalkane is made to react with a metal in presence of dry ether. That's when you get higher alkane. Alkane is obtained. ಈ ಆಲ್ಕೇನ್ ಪ್ರಾಡಕ್ಟ್ ನ ಹೇಗೆ ಬರೆಯೋದು? ತುಂಬಾ ಸುಲಭ. Just repeat R group twice. Connect the 2 R groups. ನೋಡಿ, write alkyl halide twice and connect the 2 R groups. ಅಷ್ಟೇ. ಯಾವುದೇ ಹ್ಯಾಲೋ ಆಲ್ಕೇನ್ ಕೊಟ್ಟು ನಿಮಗೆ ವರ್ಡ್ಸ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಬರೋ ಪ್ರಾಡಕ್ಟ್ ಏನು ಅಂತ ಕೇಳಿದ್ರೆ ನೀವು ತುಂಬಾ ಸುಲಭವಾಗಿ ಪ್ರಾಡಕ್ಟ್ ನ ಬರೀಬಹುದು. ಹೇಗೆ? ಜಾಯಿನ್ ದ 2 R groups. ಹ್ಯಾಲೋ ಆಲ್ಕೇನ್ ಫಾರ್ಮುಲಾನ 2 ಸಲ ಬರ್ಕೊಳ್ಳಿ, ಆಮೇಲೆ ಅದರಲ್ಲಿರೋ ಆರ್ ಗ್ರೂಪ್ ಅಥವಾ ಆಲ್ಕೈಲ್ ಗ್ರೂಪ್ ನ ಜಾಯಿನ್ ಮಾಡಿ. ದೆನ್ ವಿಲ್ ಗೆಟ್ ಆಲ್ಕೈಲ್. ಬಟ್ ಆಕ್ಚುಯಲ್ ಮೆಕ್ಯಾನಿಸಮ್ ಬೇರೆ ತರ ಇದೆ. ರಿಯಾಕ್ಷನ್ ಮೆಕ್ಯಾನಿಸಮ್ ಇಸ್ ಕಂಪ್ಲೀಟ್ ಡಿಫರೆಂಟ್. ಇಟ್ಸ್ ಅ ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್. ವರ್ಡ್ಸ್ ರಿಯಾಕ್ಷನ್ ಇದೆಯಲ್ಲ ಅದು ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್. ಆದ್ರೆ ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿ ಪ್ರಾಡಕ್ಟ್ ಬರೆಯೋದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ಈ ತರ ಕೆಲವು ಮೆಥಡ್ಸ್ ನ ನೀವು ಕಲ್ತ್ಕೋಬೇಕು. So words reaction ಅಲ್ಲಿ you just link the two R groups ಅಷ್ಟೇ. ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ. C2H5Cl ಎಕ್ಸಾಂಪಲ್ ಈ ತರ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. C2H5Cl arrow mark, sodium in dry ether, sodium in dry ether. ಸೋಡಿಯಂ ಮತ್ತೆ ಡ್ರೈ ಈಥರ್ ನೋಡಿದ ತಕ್ಷಣ ನಿಮ್ಗೆ ವರ್ಡ್ಸ್ ರಿಯಾಕ್ಷನ್ ನೆನಪಾಗಬೇಕು. ಅಂಡ್ you now need to predict the alkane product. How? Just repeat alkyl group twice. In alkyl group ಏನಿದೆ ethyl. ethyl ಅಂದ್ರೇನು? CH3CH2 CH3CH2 ಅದನ್ನ ಎರಡು ಸಲ ಬರೆದ್ರಾಯ್ತು ಅಷ್ಟೇ. ಓಕೆ, CH2CH3. That's all. What you get is butane. What you get is butane. Very simple. Very simple. Okay. Next, you have what if you take mixture of haloalkanes? ಒಂದೇ ತರಹದ haloalkane ತಗೊಳ್ಳೋದ್ರ ಬದಲು ನಿಮ್ಮ ಹತ್ರ ಮಿಕ್ಸ್ಚರ್ ಇದ್ರೆ, ಅಂದ್ರೆ 2 different types of haloalkanes, ಅವಾಗ ನೋಡಿ ಏನಾಗ್ತಾ ಇದೆ. You get 3 compounds, mixture of 3 alkanes. Mixture of 3 alkanes. Okay, yeah. So how do you get these products? Again, nodi, CH3CH3 gives you ethane. C2H5 twice gives you butane. Amele you can have one more combination, C2H5CH3, that is propane. So you get ethane, propane and butane. Ethane, propane, butane. You get all the 3. Okay, that's good. Next, that's about words reaction. Let's go to the next method. Yes, decarboxylation. Next method is decarboxylation. Decarboxylation andreno? Removal of carbon dioxide. Removal of carbon dioxide. Just like how you say removal of water as dehydration, removal of hydrogen as dehydrogenation, removal of halogen as dehalogenation. Similarly, removal of carbon dioxide is decarboxylation. So how do you carry out decarboxylation? You heat sodium salt of carboxylic acid. Sodium salt of carboxylic acid. Sodium salt of carboxylic acid. Okay. ಇದನ್ನ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಜೊತೆ ಹೀಟ್ ಮಾಡಿದಾಗ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ವಿಲ್ ಗೆಟ್ ರಿಮೂವ್ಡ್. ಬಟ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅಲ್ಲಿ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಕಾಣಿಸ್ತಿಲ್ವಲ್ಲ. ಐ ಆಮ್ ಟೆಲಿಂಗ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಇಸ್ ಗೆಟಿಂಗ್ ರಿಮೂವ್ಡ್. ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲಿ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಇರಬೇಕಾಗಿತ್ತು, ಬಟ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಇಲ್ಲ. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಕಾರ್ಬೋನೇಟ್. ಯು ನೋ ವೈ? ಬಿಕಾಸ್ ಮೀಡಿಯಂ ಇಸ್ ಆಲ್ಕಲೈನ್. ಇನ್ ಆಲ್ಕಲೈನ್ ಮೀಡಿಯಂ, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಅಸಿಡಿಕ್. Carbon dioxide acidic reacts with sodium hydroxide, a base, to form sodium carbonate salt. Simple. And in the meantime, ಏನಾಗುತ್ತೆ ನೋಡಿ, R gets attached to H. You get RH. Here again, you are converting carboxylate into alkane. Simple method. Simple method. This is called soda lime decarboxylation. ಈ ಮಿಕ್ಸ್ಚರ್ ಇದೆಯಲ್ಲ, NaOH ಪ್ಲಸ್ ಕ್ಯಾಲ್ಸಿಯಂ ಆಕ್ಸೈಡ್, ಈ ಮಿಕ್ಸ್ಚರ್ ನ ಸೋಡಾ ಲೈಮ್ ಡಿಕಾರ್ಬಾಕ್ಸಿಲೇಷನ್ ಅಂತ ಕರೀತಾರೆ. ಸೋಡಾ ಲೈಮ್ carboxylation. Good. That is decarboxylation. Now, there is one more way you can bring about decarboxylation. Hegado? It's through electrolysis, by using electricity. By making use of electricity. Okay, you can bring about decarboxylation. How do you achieve it? Again, take same sodium salt of carboxylic acid, make a solution out of it, aqueous solution, subject it to electrolysis. Electrolysis ಅಂದ್ರೆ ನಿಮಗೆಲ್ಲ ಗೊತ್ತಿದೆ, ನೀವು electrochemistry chapter ಇದನ್ನು ಓದಿರ್ತೀರಾ. You dip 2 electrodes connected to a battery to this aqueous solution called electrolyte, and you'll have substances liberated at cathode. Okay, and anode. Cathode being negative terminal and anode being positive terminal here. Okay, So what are the products? Products nodi alkane baratte. You get alkane, carbon dioxide, both at anode, and you get hydrogen at cathode. Hydrogen is liberated at cathode, alkane is liberated at anode. This is what is Call-based electrolysis. Call-based electrolysis. Yes, yes. Okay. Now one limitation is there. In method, you can't prepare alkanes with odd number carbon atoms. Odd number carbon atoms like propane, pentane, heptane. These compounds is one method alla. And you can't prepare methane by this method. Minimum 2 carbon atoms irbe. Methane na ee method inda prepare ಮಾಡೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ. Okay, right. That's about methods of preparations of alkanes. So istodgagle ನಾವು ಎಷ್ಟು reactions ನೋಡಿದೀವಿ almost I think 5 reactions. Yes, ಎಲ್ಲ reaction important once the revision revise ಮಾಡಿ. Okay, 4 reaction 4 and reaction 5. Yes. Next we'll now go to physical properties. Physical properties of alkanes. Again, not much. Should remember first 4 members gases, next 13 members andre C1 to C4 methane to butane gases, pentane to say heptadecane liquid, more than C17 solids. Boiling point decreases on branching. Branching ಜಾಸ್ತಿ ಆದ್ರೆ alkanes ಅಲ್ಲಿ boiling point ಕಡಿಮೆ ಆಗುತ್ತೆ. For example, if you take butane and isobutane, butane has a higher boiling point than isobutane because branching reduces surface area. Branching reduces surface area. Branching reduces surface area. Okay, good. So that is one thing. And then boiling point proportional to van der Waals forces nimgeಲ್ಲ ಗೊತ್ತಿದ್ದು. And solubility. Alkanes are not soluble in water. They are only soluble in non-polar solvents like benzene, carbon tetrachloride, and so on. And remember this phrase. This phrase ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Like dissolves like. Like dissolves like. ಯಾವುದಾದ್ರೂ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಇನ್ನೊಂದು ಸಾಲ್ವೆಂಟ್ ಡಿಸಾಲ್ವ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಅದ್ರ ಫೋರ್ಸಸ್ ಸಿಮಿಲರ್ ಇರಬೇಕು. ಸೊ ಆಲ್ಕೇನ್ಸ್ ನಿಮಗೆ ನಾನ್ ಪೋಲಾರ್ ಸಾಲ್ವೆಂಟ್ಸ್ ಅಲ್ಲಿ ಮಾತ್ರ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ, ಪೋಲಾರ್ ಸಾಲ್ವೆಂಟ್ಸ್ ಅಲ್ಲಿ ಅಲ್ಲ, ಬಿಕಾಸ್ ಆಲ್ಕೇನ್ಸ್ ಆರ್ ಆಲ್ಸೋ ನಾನ್ ಪೋಲಾರ್. ಓಕೆ, ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್. Now let us go to chemical properties. When it comes to chemical properties, nothing much, because alkanes are relatively stable and inert. Alkanes relatively stable and inert. Relatively stable and inert. They usually don't get into chemical reactions because they have strong carbon and strong carbon hydrogen bonds. Strong carbon and carbon hydrogen bonds. That's the reason why alkanes react under drastic conditions. Ordinary conditions alli alkanes react agalla. Yenadu drastic conditions? It can be high temperature, or it can be in the presence of diffuse sunlight or UV light. Under those conditions, alkanes react. Now, what kind of reactions do they undergo? They undergo free radical substitution reaction. Free radical substitution reaction. Again, first chapter tilkondidvi. Organic reactions can be classified into the following types. 1, addition. 2, substitution. 3, elimination. This is substitution, wherein 1 hydrogen atom of methane is replaced by chlorine to give chloromethane. 1 more gets replaced to give you dichloromethane. The substitution continues to give you chloroform, and it ends with the formation of carbon tetrachloride. Carbon tetrachloride form ಆದ್ಮೇಲೆ ಮತ್ತೆ substitution ಆಗಲ್ಲ. ಯಾಕೆ ಅಂತ ನಿಮಗೆಲ್ಲ ಗೊತ್ತು. There are no more hydrogens to be substituted. This is the final product. And this reaction occurs in 3 steps: initiation step, propagation step, termination step. ಯಾವತ್ತು ನೆನಪಿಟ್ಕೊಳ್ಳಿ, any free radical mechanism will involve these 3 steps: chain initiation, chain propagation, chain termination. Chain initiation starts the reaction, propagation continues the reaction, termination brings the reaction to an end. ನಾವು ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಯಾವ ತರ ಪ್ರಶ್ನೆಗಳು ಬರುತ್ತೆ ಅಂದ್ರೆ, ಒಂದು ರಿಯಾಕ್ಷನ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಅದು ಇನಿಷಿಯೇಷನ್ ನ, ಪ್ರಾಪಗೇಷನ್, ಟರ್ಮಿನೇಷನ್ ಅಂತ ನೀವು ಚೆಕ್ ಮಾಡಬೇಕು. ಓಕೆ, ಹೌ ಟು ಡೂ ಇಟ್? ಸಿಂಪಲ್ ಐಡಿಯಾ ನೋಡಿ. If you find free radicals on the product side only and not reactant side, it is initiation. If you find free radicals on both sides, reactants, products, ಎರಡೂ ಕಡೆ ನಿಮಗೆ free radicals ಕಾಣಿಸಿದ್ರೆ ಅದು propagation. And if you find free radicals only on the reactant side, not on the product side, then it is termination. Simple logic to recognize initiation, propagation, and termination. Okay, good. So that's about free radical substitution reaction. Okay, ಇದಲ್ಲದೆ free radical substitution ಅಲ್ಲದೆ alkanes ಇನ್ನೂ ಕೆಲವು reactions execute ಮಾಡುತ್ತೆ. ಏನದು? catalytic oxidation. If you oxidize alkanes in presence of oxygen, in presence of a catalyst, then you get variety of products. Sorry, oxidation ಅಂದ್ರೆ obviously ಇಲ್ಲಿ oxygen ಇದ್ದೇ ಇದೆ. In addition to that, you will use a catalyst. That's when you get a variety of products. ಈ ಮೂರು ರಿಯಾಕ್ಷನ್ ನೀವು ಬರ್ದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೋಬೇಕು. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇದ್ರ ಮೇಲೆ ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮ್ ಕ್ವಶನ್ಸ್ ಬರೋ ಸಾಧ್ಯತೆ ತುಂಬಾನೇ ಇದೆ. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಮೀಥೇನ್ ಆಕ್ಸಿಡೈಸ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಕಾಪರ್ ಆಸ್ ಕ್ಯಾಟಲಿಸ್ಟ್, ಯು ಗೆಟ್ ಮೆಥನಾಲ್. ನೋಡಿ, ಮೀಥೇನ್ ಪ್ಲಸ್ ಆಕ್ಸಿಜನ್, ಕಾಪರ್ ಕ್ಯಾಟಲಿಸ್ಟ್, ಮೆಥನಾಲ್. ಅದೇ ಮೀಥೇನ್ ಅದೇ ಆಕ್ಸಿಜನ್ ಜೊತೆಗೆ ಮಾಲಿಬ್ಡಿನಮ್ ಆಕ್ಸೈಡ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಇದ್ದಾಗ ಮೆಥನಾಲ್ ಕೊಡುತ್ತೆ. ಮೆಥನಾಲ್ ಬದಲು ಮೆಥನಾಲ್ ಬದಲಿಗೆ ಮೆಥನಾಲ್ ಬರುತ್ತೆ. ಅಂದ್ರೆ ಕ್ಯಾಟಲಿಸ್ಟ್ ಇಲ್ಲಿ ಅಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಕ್ಯಾಟಲಿಸ್ಟ್ ಇಸ್ ಸ್ಪೆಸಿಫಿಕ್ ಹಿಯರ್, ಸ್ಪೆಸಿಫಿಸಿಟಿ. ನೋಡಿ, ಮೀಥೇನೆ ತಗೊಂಡಿದ್ದೀರಾ, ಮತ್ತೆ ಅದನ್ನ ಆಕ್ಸಿಜನ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಮಾಡಿದ್ದೀರಾ, ಆದ್ರೂ ಇಲ್ಲಿ ನಿಮ್ಗೆ ಮೆಥನಾಲ್ ಬರುತ್ತೆ. ಬಿಕಾಸ್ ಯು ಹ್ಯಾವ್ ಟೇಕನ್ ಮಾಲಿಬ್ಡಿನಮ್ ಆಕ್ಸೈಡ್ as catalyst. Again, 2-methyl propane with a strong oxidizing agent like KMnO4 gives you tertiary butyl alcohol. ಇದನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು. Okay, good. That's about catalytic oxidation. Catalytic oxidation ಅಂದ್ರೇನು? Carrying out oxidation in presence of a catalyst. Very similar to catalytic reduction. Next reaction, isomerization. ಏನಿದು isomerization ಅಂದ್ರೆ? Very simple. In these reactions, straight chain alkanes on heating in presence of aluminum chloride and HCl get converted to branch chain alkanes. Straight chain alkanes irodu branch alkanes agutte. This process is called isomerization. And isomerization required ingredients ಅಥವಾ required reagents ಏನು? anhydrous AlCl3, dry HCl gas. ಈ ಎರಡು ಸಬ್ಸ್ಟೆನ್ಸ್ ಇರಲೇಬೇಕು, ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಇದಿಲ್ಲ ಅಂದ್ರೆ isomerization reaction ಆಗಲ್ಲ. Okay, so that is one way of converting straight chain compounds into branch chain compounds. Next, aromatization. Aromatization is another process wherein a normal alkane upon heating with chromium oxide and aluminum oxide, will undergo two events. Cyclize ಆಗುತ್ತೆ, at the same time hydrogen is also lost. It gets converted to a cycle or a ring, and hydrogen is also lost to give you this aromatic compound benzene. Benzene is the aromatic compound you get here. Yes, this is called as aromatization, converting an alkane into an aromatic compound. And then reaction with steam, methane plus water gives you this combination, carbon monoxide and hydrogen. You call it, what do you call this? Water gas or syngas. Then final method is pyrolysis or cracking. Pyrolysis, lysis means breaking, pyro means fire. Pyrolysis or cracking, which means larger chain hydrocarbons are broken down to smaller fragments. Hydrocarbons with large number of carbon atoms will be broken down to smaller pieces, smaller fragments. This is called as pyrolysis or cracking. Okay, yes, with this, yes, we complete. Okay, alkanes. In last section ಇದೆ, ಏನದು? Conformations of alkanes. Alkanes can exist in a number of conformations. Conformations ಅಂದ್ರೆ the structures differ in their spatial orientation. Observe this. ಇಲ್ಲಿ ನೋಡಿ, ethane ನ ಎಕ್ಸಾಂಪಲ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದೀವಿ. Ethane. This is one spatial orientation. Two, For ethane and other alkanes, there can be a carbon-carbon single bond rotation. Nodi, imagine this to be carbon-carbon single bond. Idana carbon-carbon single bond ankoli, you can have the groups rotating about it. Okay, that leads to various different orientations. You call these different orientations as conformers. Is tara conformers ide infinite number of conformations, but out of all that, two forms are prominent. Yavudadu? Ethane, this form, this is called eclipsed form, eclipsed, and this is staggered. Okay, I want to ask the class now, which is more stable according to you, eclipsed or staggered? Come on, eclipsed or staggered, which is more stable? Chat section alli type ಮಾಡಿ. Between eclipsed and staggered, which is more stable? Okay, one answer eclipsed anta bandide. Okay, majority of you telling eclipsed. So one trend I am noticing is ಒಬ್ರು eclipsed ಹೇಳಿದ್ರೆ ಎಲ್ಲರೂ eclipsed ಹೇಳ್ತೀರಾ. Okay, it's not correct. Eclipse is not the answer. Most stable configuration staggered. ಯಾಕೆ ನೋಡೋಣ. One second. Yeah, look at this. Let me give you the next information. One second. See, which conformation of ethane is most stable with least energy? It is the staggered conformation. That is the most stable with the least energy, staggered conformation. I'll tell you why. In staggered conformation, see, the hydrogen atoms are quite far apart. The repulsion between the bonds is less. Repulsion between the bonds is less. You therefore call it less torsional strain. Torsional strain ಅನ್ನೋ ಪದ ಬಳಕೆ ಮಾಡ್ತೀವಿ. Okay, torsional strain, and you can see for every 60-degree rotation, the conformers interconvert. The eclipse form gets converted to staggered form, staggered to eclipse. ಈ ತರ interconvert ಆಗುತ್ತೆ for every 60-degree rotation. Okay, this animation will give you an idea. Observe ಮಾಡಿ. See, ನೀವು ಪ್ರತಿ 60-degree rotate ಮಾಡಿದಾಗ್ಲೂ ಅದು ಕಾನ್ಫರ್ಮೇಷನ್ ಬದಲಾಯಿಸ್ತಾ ಹೋಗುತ್ತೆ ನೋಡಿ. ಈಗ ಸ್ಟ್ಯಾಗರ್ಡ್ ಇದೆ, 60-degree ಆಯ್ತು, ಎಕ್ಲಿಪ್ಸ್ ಆಯ್ತು, ಮತ್ತೆ 60-degree ಸ್ಟ್ಯಾಗರ್ಡ್ ಆಗುತ್ತೆ ನೋಡಿ. Yes, that is how conformations are. Okay, with this we complete alkanes. This is all about alkanes. Now let us take up multiple choice questions on alkanes. Give me a minute. Yes, dear students, just give me a minute. I'll load the worksheet. Till then, you can keep revising these concepts. So once I post the question, yes. Now the first question. Let me see who will take up the first question. First question, which of the following is the correct IUPAC name? Give your answer in the chat section. Which option? Which of the following is the correct IUPAC name? ಅಂದ್ರೆ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋ 4 ಆಪ್ಷನ್ಗಳಲ್ಲಿ ಯಾವ ಆಪ್ಷನ್ IUPAC ರೂಲ್ಸ್ ಗೆ ಅನುಗುಣವಾಗಿದೆ, IUPAC ರೂಲ್ಸ್ ಗೆ ತಕ್ಕಾಗಿದೆ. ಓಕೆ, tell me which option. Check it out carefully. Okay, Aishwarya says B. Good attempt. Let's see. Let's check it. Okay, let's check it one by one. 2-methyl 3-pentane structure ಬರೀತೀವಿ ನೋಡಿ. 2-methyl 3-pentane. 1 second again. Yeah. 2-methyl 3-ethyl pentane. So 1, 2, 3, 4, 5. Second position methyl. Third position ethyl. So longest chain ಏನಾಗುತ್ತೆ 1, 2, 3, 4, 5. 5 ಹೇಳ್ಕೊಳುತ್ತೆ. Second position methyl. Third position ethyl. But there is one mistake here. Can anyone point out mistake in option A? Option A ನಲ್ಲಿ ಏನು ತಪ್ಪಿದೆ ಕಂಡು ಹಿಡಿತೀರಾ? Let me see. Option A. What is the mistake? Come on, be quick. Mistake is alphabetical order list of substituents. ನಾನು ಹೋದ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ. Methyl, ethyl. ಇದರ ಮಧ್ಯ ಫಸ್ಟ್ ಬರೋದು ಯಾವುದು alphabetical order ಅಲ್ಲಿ? Ethyl. So it should be named ethyl and then methyl. So ಎಲ್ಲಿದೆ ನೋಡಿ ಆ ಹೆಸರು 3-ethyl 2-methyl pentane. This is correct. This will be more appropriate. 1 second. Yeah. Let me set a pen. 3-ethyl 2-methyl because ethyl comes first in alphabetical order than M. Yes, let me highlight that. Ethyl. Yes, this is the answer. Next question. We'll check the next question. Question number 2. Methane is formed when? When is methane obtained? Sodium acetate is heated with soda lime. Yes. This is decarboxylation reaction. Hope you remember it. CH3CONA plus NaOH. Calcium oxide. What happens? Na2CO3 is formed and you get methane. Methane plus Na2CO3. Now, this is one correct reaction. But all the above options ಕೊಟ್ಟಿದೆ ಸ್ವಲ್ಪ ನೀವು ಹುಷಾರಾಗಿರಬೇಕು. Okay? You should check the other options as well. You know, sodium acetate ಆಯ್ತು, we proved it. Iodomethane is reduced. See, this is iodomethane. Reduction means what? Removal of non-metal, addition of hydrogen. So iodomethane reduced to methane is correct. So statement 2 is correct. Aluminum carbide is reacted with water. Aluminum carbide Al4C3 reacts with water to give you what set of products? One of you come on. AlCl3 plus water hydrolysis, you get methane plus aluminum hydroxide. This is the reaction. So first reaction is also correct. Second reaction is also correct. So is third reaction. So our correct answer becomes option D. 1 second. Yes. Here you have decarboxylation, reduction, and hydrolysis. All the 4. We say. So all the 4 is the answer. All the above. That was question number 2. Now let's go to question number 3. Yes. Please read the question carefully and then answer. Careful. ಓದ್ಕೊಂಡು ಉತ್ತರ ಹೇಳಿ. Anybody with the answer? Let me see. Okay. Let me work this out for you. ಯಾರ್ಯಾರು correct answer ಹೇಳಿದಾರೆ ನೋಡೋಣ. Okay, we have Ganesh suggesting B. Manoj Kumar B. Ravi again suggests B. Okay, ನೋಡೋಣ check ಮಾಡೋಣ. Okay. Question number 3. Mixture of 2 organic compounds. Mixture of 2 organic compounds was treated with sodium metal in ether solution. Isobutane was obtained as product. The two chlorine compounds are very important. Very good question. Please mark it. Please mark it important. Important. Again, product isobutane anta. Isobutane is a product. Let me write the product now. 1 second. Just wait for a couple of minutes, dear students. My system has got up. 1 second. One second. Okay. So see, this isobutane is what is given. Isobutane is CH3, CH, one day carbon, one day hydrogen. CH3, CH3. Now, if this is the compound to be formed from Wood's reaction, look at this. This must be from two different haloalkanes. ಎರಡು haloalkanes ಇದೆ ಬಂದಿದೆ ಅಂತ ನಮಗೆ ಅರ್ಥ ಆಗುತ್ತೆ. Okay. So how to find that out? Easy. Now separate out one from the rest of it. Separate isopropyl separate. So just attach halogen atoms to them. Chloromethane plus CH3, CH2, CH3. Bromopropane, 2 bromopropane, chloromethane. Yes, these are the products. Yeah, which option is right? Therefore, this eventually gives the halogen. So this will be CH3, CH, CH3, Cl. Here also there's only one H. Yes. So you get CH3Cl plus CH3CH, ClCH3. Okay. Which are the options are correct? Chloromethane or methyl chloride. Yes. And propyl chloride, isopropyl chloride. Reactant. Isopropyl chloride, as you all can see. Check this. 1 second. The system has got stuck. Just a second. Yeah, now it's okay. We'll continue. So butane and isopropyl chloride and methyl chloride. Isopropyl chloride one though. See, this is isopropyl chloride. Isopropyl chloride, and this is methyl chloride anyway. So this is the answer. Just a second. Let me highlight both. Isopropyl chloride, methyl chloride. Yes, that was third question. Here question number 4 bani. Electrolysis of aqueous solution. Electrolysis of aqueous solution of sodium butanoate. Sodium butanoate. This is something we learned under decarboxylation reaction. General ಹೇಗಿರುತ್ತೆ reaction ನೋಡಿ ಇಲ್ಲಿ. General reaction ಕೊಟ್ಬಿಡ್ತೀವಿ first ನಿಮಗೆ. COO Na plus water giving rise to electrolysis or using electrolysis to get the products here. Now, what was the method I told you? Method, remove CO2, develop R group. Astay, easy. Remove CO2 remove ಮಾಡಿ ಅದೇನು R group ಇದೆ ಅದನ್ನ sari barkodi. Develop R twice. Okay. So here, if you ask me the product, it should be CO2, carbon dioxide plus R doubled up. What do you mean by R doubled up? RR. RR. Very easy. We discussed that in case of the previous chapter also. Okay, next. Yes, these are questions. Questions related to alkanes. Properties that we have discussed so far. Which of the following conformations of ethane has the lowest potential energy? Come on. Which of the following conformations of ethane? ಎರಡು ಕಾನ್ಫರ್ಮೇಷನ್ ನೋಡಿದ್ವಿ ಎಕ್ಲಿಪ್ಸ್ ಮತ್ತೆ ಸ್ಟಾಗ್ನರ್ಡ್ ಯಾವ ಸ್ಟೇಬಲ್ ಆಗಿತ್ತು let me check the chat section you must give the correct answer for this yes b yes most of it is suggesting b staggered configuration is the most stable eclipse is the least stable one second okay I'm putting a line and that's not visible so just a second yeah all conformations yes question number 6 the correct order of boiling points of 2,2 dimethyl propane 2 methyl butane and n pentane ಮೊದಲು ನಾವು ಇದು ಸ್ಟ್ರಕ್ಚರ್ಸ್ ನ ಬರ್ಕೊಂಡ್ಬಿಡೋಣ ನಮ್ಮ ಕಡೆ ಓಕೆ we'll write down its structures just a second first one given is 2,2 dimethyl propane 1 2 3 propane 2,2 dimethyl second one is 2 methyl butane 1 2 3 4 2 methyl butane and that of third structure is n pentane 1 2 3 4 5 n pentane okay now here please find out which has more branching 2,2 dimethyl propane has more branching hence least boiling point followed by 2 methyl butane followed by just pentane n pentane third option is n pentane 2,2 dimethyl propane and 2 methyl butane yes this is the correct option okay let me just okay, one second it's option A anta gottagide we'll just highlight it one second n pentane 2,2 dimethyl propane 2 methyl butane these represent the boiling point in the decreasing order right yes now check this out the propagation step in chlorination of methane propagation step ನಾನು ಪ್ರಾಪಗೇಷನ್ ಕಂಡು ಹಿಡಿಯೋದಕ್ಕೆ propagation step ಕಂಡು ಹಿಡಿಯೋದಕ್ಕೆ ಒಂದು ಮೆಥಡ್ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೆ use that method and solve the question let me see how can one recognize this propagation step quickly if you remember I told you if you find only free radicals on the product side it is initiation free radicals on both products and reactant side propagation free radicals only on the reaction side termination okay ilnodi step 1 reactants on the free radicals are on the reactant side so it will be propagation look at B all the free radicals combined is termination C you can find free radicals on the reactant side as well as product side so sorry first one is initiation one second small correction and change it yes first one is actually initiation second one is propagation one second. Yes, this is initiation. This is termination, and this is propagation. Okay, next. The mono-bromo products of the reaction of 2-methyl-butane with bromine in presence of sunlight is, 2-methyl-butane. It's a substituted alkane. 2-methyl-butane is made to react with bromine in presence of sunlight. First of all, why this condition is required? Because alkanes are less reactive. And only if you carry out the reaction in presence of sunlight or UV light or heat, it produces bromine free radicals. Otherwise, no bromine free radicals. That's the reason why it's required. Okay? Yes. Let me write the structure of 2-methyl-butane. They give the 2-methyl-butane. Let me just write it. This is 2-methyl-butane. Have a look at this. Just a second. It has still not gone to change to the pen. Okay. Yeah. 2-methyl-butane. 1, 2, 3, 4. This is brominated. And how this bromination is carried out? Bromine in presence of FeBr3. Sorry, bromine in presence of diffuse sunlight or high temperature, not FeBr3. That is for ring substitution. At next node. So how do you bring about bromination or chlorination? Heat the alkane with the halogen. That's when its homolytic fission takes place. And you get the most stable compound, that is 2-bromo-2-methyl-butane. Bromo and methyl. 2-bromo-2-methyl-butane. Okay? Why 2-bromo-2-methyl-butane? ನಿಮಗೆಲ್ಲ ಅನಿಸ್ತಿರಬಹುದು ಅಲ್ಲಿ ಎಷ್ಟೊಂದು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಇದೆ. ಇಲ್ಲೂ ಒಂದು CH3 ಇದೆ, ಇಲ್ಲೊಂದು CH3 ಇದೆ, ಇಲ್ಲೊಂದು CH2 ಇದೆ. ಎಷ್ಟೊಂದು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ನಡುವೆ ಯಾಕದು ಬರೀ ಟರ್ಷರಿ ಹೈಡ್ರೋಜನ್, ಈ ಹೈಡ್ರೋಜನ್ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು? ಬಿಕಾಸ್ ಆರ್ಡರ್ ಆಫ್ ಸ್ಟೆಬಿಲಿಟಿ ಆಫ್ ಫ್ರೀ ರಾಡಿಕಲ್ಸ್. Write it down, please. Please write down this, very, very important. Order of stability of free radicals. What is this order? Tertiary greater than secondary greater than primary. Always remember this order. Okay? Tertiary greater than secondary greater than primary. Very good. So we are completing quite a good number of questions. Question number 8 is a question on chemical property. Okay, ಈಗ question 9 ನೋಡೋಣ. Question number 9 is a method on okay, this is something we discussed already. Okay, hydrocarbons. Let me highlight it again. Hydrocarbons, you know, check ಮಾಡಿ. Higher hydrocarbons can be converted to smaller fractions by a process. What do you call this process as? Anybody? Let me see the chat section. ಏನು ಉತ್ತರಗಳು ಬಂದಿದೆ ನೋಡೋಣ. Okay, majority have suggested B and no. Sunanda says option C. Very good. That's correct. Ankita, Vinayak, all of them are of the opinion that option C. Very good. Very good. Yes, it is cracking. Or you remember there was one more term to it. Pyrolysis. This is called pyrolysis or cracking. One second. Yes. Cracking or pyrolysis. Correct answer. And this requires highlighting it. Yes, 9th ಪ್ರಶ್ನೆ ಆಯ್ತು. Now the 10th one. Let's see. Yes, that's all about the alkanes. Alkanes ಬಗ್ಗೆ ಅಷ್ಟು ಡೀಟೇಲ್ಸ್ ನಿಮಗೆ ಗೊತ್ತಿದ್ರೆ ಸಾಕು. And revise the questions. ಇದ್ರ ಜೊತೆಗೆ ನಾನು ಇವತ್ತು ಈ ವರ್ಕ್ಶೀಟ್ ಮತ್ತೆ ಇದ್ರ ಸಿನಾಪ್ಸಿಸ್ ಅಂಡ್ ಅಸೈನ್ಮೆಂಟ್ ಕಳಿಸ್ತಾ ಇರ್ತೀನಿ ಗ್ರೂಪ್ ಅಲ್ಲಿ. You will get it. Okay? Alkenes. And as you had commented in the beginning, alkenes are compounds with a carbon-carbon double bond. See, carbon-carbon double bond. They are represented by the general formula CnH2n. Let me correct it. There is a small error there. I'll correct it. This is not the general formula. General formula is CnH2n. That's the general formula. Okay. Alkanes. Sorry, alkenes. Next. Yeah, one more related to structure. Related to structure, one more point. Each carbon atom in an alkene is sp2 hybridized. sp2 hybrid. That's the reason why each carbon atom will have one unhybridized p orbital. And have a look at this. These unhybridized p orbitals will overlap sideways, laterally. You know, lateral overlap, resulting in one pi bond. See, p orbital ge ಎರಡು lobe irutte. It will have two lobes. Just because two lobes overlap, ಇದನ್ನ ಎರಡು pi bond ಅಂತ ತಪ್ಪಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬಾರ್ದು. ಇದು ಒಂದೇ pi bond ಆಗೋದು. It overlaps with two lobes, but it's still one pi bond. Okay, good. That is about structure. Next. I think we have, yes, isomerism. Important. There is this type of isomerism called geometric isomerism. Let's try to understand geometric isomerism. Tumba careful ಆಗಿ ಕೇಳಿಸ್ಕೊಳ್ಳಿ ಇದನ್ನ. This is a compound called butene. This will be called butene. Let me write it. Yes, butene. Butene. Okay. Now let us interchange groups. Groups interchange ಮಾಡಿ. I'll put CH3 below and H I'll take it to the top. I am interchanging groups. See what do you get? ಏನು ಬರುತ್ತೆ ನೋಡಿ? Yes. CH3 has come down, H has gone up. Now because of this interchange, this structure here is completely different from this structure. Or in other words, I can say you have different spatial orientation for atoms around the double bond. Such isomers with different spatial orientation around the carbon-carbon double bond, you call them geometric isomers. See, different molecules, they are different molecules, hence they show geometrical isomerism. Geometrical isomerism. Let's now try out one more aspect. ಇದನ್ನ ಫ್ಲಿಪ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂತ. ಲೆಟ್ಸ್ ಫ್ಲಿಪ್ ಇಟ್ ಓವರ್. ಫ್ಲಿಪ್ ಇಟ್ ಓವರ್ ಅಂದ್ರೆ ನೀವು ಹೇಗೆ ಪೇಜ್ ನ ತಿರುಗಿಸ್ತೀರಾ ಬುಕ್ ಅಲ್ಲಿ, ಅದೇ ತರ ಫ್ಲಿಪ್ ಇಟ್ ಓವರ್ ಲೈಕ್ ದಿಸ್. ಇಫ್ ಯು ಫ್ಲಿಪ್ ಓವರ್ ದ ಸ್ಟ್ರಕ್ಚರ್, ವಾಟ್ ಯು ಗೆಟ್? ಸಿ CH3 C double bond CH3. It is still not the same as this. ನೋಡಿ, ಇದನ್ನ ಸ್ಟ್ರಕ್ಚರ್ 1 ಅಂತ ನಾವು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ರೆ, ಇದನ್ನ ಸ್ಟ್ರಕ್ಚರ್ 2 ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ರೆ, ಸ್ಟ್ರಕ್ಚರ್ 2 is different from structure 1. You flip over structure 2, you still get something different from structure 1. And this flipped over structure is same as structure 2. Adu idu same, ವ್ಯತ್ಯಾಸ ಇರಲ್ಲ. Because if you flip it over, you get point to point match. Okay. This type of isomerism is called geometrical isomerism. Geometrical isomerism. Okay. ಇಲ್ಲಿ ನಾವು ತಿಳ್ಕೊಳ್ಬೇಕಾಗಿರೋ ಇನ್ನೊಂದು ಮುಖ್ಯವಾದ ಅಂಶ ಏನು ಅಂದ್ರೆ, how to recognize or find out whether a given compound shows geometrical isomerism or not. ಒಂದು ಆಲ್ಕೀನು geometrical isomerism ನ ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತಿದ್ಯಾ ಇಲ್ವಾ ಅಂತ ಹೇಗೆ ತಿಳ್ಕೊಳ್ಳೋದು? There are two conditions. If those two conditions are satisfied, then yes, it shows geometrical isomerism. Let us see what those conditions are. Our conditions ಏನು ಅಂತ ನೋಡೋಣ. Okay, one by one. Look at this compound. Look at this compound. This does not exhibit geometrical isomerism. Doesn't exhibit geometrical isomerism. Okay, next one. Look at this compound. Exhibits geometrical isomerism. You'll notice. First one. Okay. First compound does not exhibit geometrical isomerism. Second compound also doesn't exhibit geometrical isomerism. Third compound exhibits geometrical isomerism. From these three observations, from these three compounds, it's very clear that for a compound to show geometrical isomerism, it should follow the given conditions here. What are the conditions? Let me just show it to you. Yes, these are the conditions. Conditions for geometrical isomerism. Yenado? One, restricted rotation. Restricted rotation about double bond. See, single bond idre nodi, carbon carbon single bond easy rotate agutte about the groups. So there is easy rotation possible about carbon carbon single bonds. That's why alkanes showed different conformations, staggered, eclipsed, ಅದೆಲ್ಲ ಯಾಕೆ ಅಂದ್ರೆ there is carbon carbon rotation possible. Now instead let's say single bond ಬದಲಿಗೆ double bond ಇದ್ರೆ ನೋಡಿ, what if I have a double bond like this? Imagine I have a double bond. Can I rotate? ನೀವು ಟ್ರೈ ಮಾಡಿ ನೋಡಿ. ಸಿಂಗಲ್ ಬಾಂಡ್ ಇದ್ದಾಗ ಈಸಿ ರೊಟೇಟ್ ಮಾಡಬಹುದು. ಡಬಲ್ ಬಾಂಡ್ ಇದ್ರೆ ರೊಟೇಷನ್ ಆಗಲ್ಲ. ದೇರ್ ಇಸ್ ರೆಸ್ಟ್ರಿಕ್ಟೆಡ್ ರೊಟೇಷನ್. ಇನ್ನು ನೀವು ಫೋರ್ಸ್ಫುಲ್ ಆಗಿ ರೊಟೇಟ್ ಮಾಡಿ ಟ್ರೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? Bonds get broken down. Okay, therefore single bond rotation easy, double bond rotation is restricted, difficult. So that because of that restricted rotation, you can't have groups interchanged, and that's one condition for geometric isomerism. What's another condition? This is another important condition. Okay, each carbon atom of the double bond should be attached to different atoms or groups. Iga ee compound number 1 nodi, I am marking it. See compound number 1, it doesn't show geometric isomerism. Double bond ide, double bond idru geometric isomerism exhibit madalla. Yake? Check this. These two groups are identical. Remember, each carbon atom should have different groups. Only then it shows geometrical isomerism. These two are identical, therefore no geometrical isomerism. Then let's come to compound 2. Again, methyl groups identical. In fact, compound 1 alli nodi hydrogen atoms same ide. So eradu carbon atom ge identical groups attach agirutte. That's when it cannot show geometrical isomerism. Compound 2 nodi, first carbon different groups, hydrogen chlorine different groups. First carbon here groups different, bere ide. Ade second carbon atom nodi, na highlight ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನೋಡಿ, it has identical groups. Condition ಏನು? Each carbon of double bond, ಬರೀ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ ಅಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಗ್ರೂಪ್ಸ್ ಇದ್ರೆ ಸಾಕಾಗಲ್ಲ. Each carbon atom of double bond should have different groups attached. So here second carbon has again identical groups, no geometrical isomerism. ಅದೇ ನೀವು ಥರ್ಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಬನ್ನಿ, ಥರ್ಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಲ್ಲಿ ಲೋಗೋ ಇಂದ ಸರಿಯಾಗಿ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ನಿಮಗೆ. ಅದೇ ಕಾಂಪೌಂಡ್ ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ ನೋಡಿ, ಥರ್ಡ್ ಕಾರ್ಬನ್ ಆಟಮ್. Each carbon atom has different groups attached. Carbon 1 nodi, I am highlighting it, has CH3 and H different. Carbon 2 has CH3 and H different. So each carbon atom has different atoms or groups, and therefore it exhibits geometrical isomerism. Okay, yes dear students, that's about geometrical isomerism in alkenes. Very 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 important. Okay, all of you should be aware of this. Geometrical isomerism is one important section. That's good. Okay, hopefully I hope that all of you have understood this concept. Okay, yes. Next slide, we'll move on. Yes, methods of preparation. We discussed methods of preparations of alkanes today. We'll also discuss methods of preparation of alkenes. I am coming to the last part of the session. I have around 10 minutes more. Let's see how much we can cover here. Okay, one more method of preparation of alkene is from alkynes itself. See, ನಾವು alkenes methods of preparation discuss ಮಾಡಬೇಕಾದ್ರೆ ಒಂದು ಮೆಥಡ್ ನೋಡಿದ್ವಿ, ಏನದು? Alkynes and alkenes upon catalytic hydrogenation. If you add hydrogen gas, it gives you alkanes. Similarly, alkenes upon catalytic hydrogenation is giving you alkenes. Sorry, alkynes. Alkynes upon catalytic hydrogenation can end up with alkenes. But there is one complication. Yenadu? The alkene formed further gets reduced, further gets hydrogenated to an alkane. So alkene stage alli reaction na nilsaduk agodilla. Alkene stage alli reaction na stop madoduk agodilla, because alkene formed also is highly reactive. It reacts with hydrogen again to give you alkane. ಆದ್ರಿಂದ ನೀವೇನ್ ಮಾಡ್ಬೇಕು, ಇಲ್ಲಿ ಪಾರ್ಷಿಯಲ್ ಹೈಡ್ರೋಜನೇಷನ್ ನ ಟೆಸ್ಟ್ ಮಾಡಬೇಕು. ಯು ಹ್ಯಾವ್ ಟು ಕಂಡಕ್ಟ್ ಪಾರ್ಷಿಯಲ್ ಹೈಡ್ರೋಜನೇಷನ್. ಪಾರ್ಷಿಯಲ್ ಹೈಡ್ರೋಜನೇಷನ್ ಟ್ರೈ ಮಾಡಬೇಕು. ಏನಿದು ಪಾರ್ಷಿಯಲ್ ಹೈಡ್ರೋಜನೇಷನ್? ಪಾರ್ಷಿಯಲ್ ಹೈಡ್ರೋಜನೇಷನ್ ಅಂದ್ರೆ alkynes are getting reduced only to alkenes. You prevent or stop alkenes from further getting reduced to alkanes. Alkenes na alkanes ಆಗೋದನ್ನ ತಡಿಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಹೌ, ಹೇಗ್ ಮಾಡೋದು ಅದನ್ನ? There are two methods. Method number 1, you carry out this reaction. Okay, alkyne made to react with hydrogen in presence of a specialized catalyst called Lindlar's catalyst. ಪ್ರಜ್ವಲ್, ನಿಮ್ಮ ಆಡಿಯೋ ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳಿ ಪ್ರಜ್ವಲ್. Yes, Lindlar's catalyst is nothing but poisoned palladium. So in presence of Lindlar's catalyst, reaction stops at the alkene stage. This is what is called partial hydrogenation. Alkene will not further get reduced. Okay, and one more point to notice, the alkene that you get here is called cis alkene. I didn't mention that in the previous slide. Let me mention it in geometrical isomerism slide. Okay, I hope all of you know this. Under geometrical isomerism, you get two different orientations, right? You get two different structures. That structure which has methyl groups on opposite side, nodi, methyl groups on opposite side of double bond, you call it trans form. Trans in Latin means opposite, right across. Whereas that structure which has methyl groups on the same side, you call it the cis form. You therefore call geometrical isomerism also as cis trans isomerism. Cis trans isomerism. Okay, so when do you consider a geometrical isomer to be cis? If identical groups are on the same side of the double bond. Nodi, methyl group ಒಂದೇ ಕಡೆ ಇದೆ. Okay, ಅದೇ trans isomer ನೋಡಿ, methyl groups are opposite to one another across the double bond. It's called trans isomer. Okay, ಇಲ್ಲಿ ಇನ್ನೊಂದು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕಾಗಿರೋ ಅಂಶ ಏನು ಅಂದ್ರೆ, in the reaction with Lindlar's catalyst, you will always get a cis alkene. You'll always end up getting cis alkene. Please remember this. Very important. ಇದನ್ನ 2 ವರ್ಷ ಸಿಟಿ ಕೇಳಿದ್ರು. 2018 ಅಲ್ಲಿ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಬಂದಿತ್ತು, 2017 ಅಲ್ಲಿ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಬಂದಿತ್ತು. So this becomes important. Okay, Lindlar's catalyst ಯೂಸ್ ಮಾಡಿದ್ರೆ ಪಾರ್ಷಿಯಲ್ ಹೈಡ್ರೋಜನೇಷನ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ನಿಮಗೆ ಸಿಸ್ ಆಲ್ಕೀನ್ ಮಾತ್ರ ಬರುತ್ತೆ. There is one more method called Burt's reduction. ನೋಡಿ, ಮೆಥಡ್ ನಂಬರ್ 2. ಇದು ಕೂಡ ಪಾರ್ಷಿಯಲ್ ರಿಡಕ್ಷನ್, ಪಾರ್ಷಿಯಲ್ ಹೈಡ್ರೋಜನೇಷನ್. ಓಕೆ, Burt's reduction ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ? You treat alkyne with lithium or sodium, lithium metal or sodium metal in liquid ammonia. This method is called Burt's reduction. And even in this method, ಈ ಮೆಥಡ್ ಅಲ್ಲೂ ನಿಮಗೆ alkyne gets converted to alkene. Alkyne gets converted to alkene, but please remember, important here, the alkyne that you get, the alkene that you get here is trans alkene. Check this, trans alkene. So very important as far as CET is concerned. ನಾ ಆಗ್ಲೇ ಹೇಳ್ದಂಗೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ CET 2017 ಅಲ್ಲಿ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಬಂದಿತ್ತು, and CET 2018 ಅಲ್ಲಿ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಬಂದಿತ್ತು. So this becomes important. Okay, this is one method of preparation of alkenes, right? So just a second, let me just find out how many more minutes I can continue the session. Okay, yeah, I still have a couple of minutes. Let me see what is the next. 1 second. Yeah, let me just check what is the next reaction. So hope you all have understood these two reactions of partial partial hydrogenation. Okay, next. Okay, next we have elimination reactions. Again, this is a reaction which you have studied in your second year haloalkanes chapter. Okay, you have studied this in your second year haloalkanes chapter, wherein you treat a haloalkane with alcoholic KOH. Alcoholic KOH is a dehydrohalogenating agent, and when you treat a haloalkane with a dehydrohalogenating agent, you end up getting an alkene. Check this out. One second. Yes. So when a haloalkane is made to react with alcoholic KOH, alcoholic solution of potassium hydroxide, one hydrogen and one halogen gets eliminated, removed. That's why you call it elimination reaction. And halogen atom gets removed with what? Which hydrogen? With a hydrogen called beta hydrogen. Beta hydrogen. Halogen gets removed with beta hydrogen. Now, what is beta hydrogen? See, carbon to which halogen is attached. Carbon to which halogen is attached is alpha carbon, and the carbon next to it is beta carbon, and all hydrogens attached to it are beta hydrogens. Okay, yes, this results in alkene formation. But here you should pay attention to one very important thing. In some cases, dehydrohalogenation may lead to more than one product. Example, nodi. In this example, you end up getting pent-2-ene and pent-1-ene. Pent-2-ene and pent-1-ene. In such cases, how to find out which is major product? Major product hege artha madkododu or adana hege kandidiyodu? Very simple. More substituted alkene is the major product. See, this is in accordance to a rule called Kcet rule. Please remember this, mark it important, Kcet rule, according to which whenever elimination reaction results in more than one product, more substituted alkene, see, alkene which has greater number of alkyl groups attached to doubly bonded carbon atoms is more stable. This is what is called as more substituted. More substituted, and this is less substituted. More substituted, and this is less substituted. Okay, and more substituted alkene is always major product. That is because it is stabilized by hyperconjugation. Now previous chapter really hyperconjugation effect ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿದ್ವಿ ಅಲ್ವಾ, same concept. Okay, so here pent-2-ene is more substituted, pent-1-ene is less substituted. Okay, this is how you prepare alkenes from haloalkanes. ಇದನ್ನು ನೀವು second year chapter ಓದಿದ್ದೀರಾ haloalkanes. Okay, right. So thank you dear students, that's it for the day. We have covered till elimination reactions. In our next class next week, we will see which are the other chemical properties and methods of preparations of alkenes, solve MCQs related to it, and after that we are left with two compounds, alkynes and aromatic compounds. Okay, we'll check it out. Thank you all of you. Thank you. So let me end the session now.